Okay. Okay, so do you see my screen?
Yes, sir.
Okay. Okay, so about last week's things, assignments and expressions. There was only one thing that I didn't mention. So let us quickly review this, whatever I have already omitted, and let us then switch to a new topic. Okay, so you have things like this, a variable equal to expression. So that is the general format of an assignment statement. Okay. What I didn't mention explicitly in the last class, that this assignment returns a value. Okay, so there are two values actually involved here. A value that is calculated by evaluating this expression. And if the type of that value happens to be different from this var, type of this variable, then C does an automatic typecasting and stores that computed value here. Okay. Now, question, which value is returned? Okay, so there are possibly two values involved, one computed and one assigned. I will soon give you an example. Returns a value which is, okay, it's not returns a value which is stored in the variable, not the value that is computed. Okay. So if the computed value and the stored value are of the same type, then these two things are essentially the same. Otherwise, there is a problem. So I will demonstrate this. So this, for example, allows me to initialize, let's say, multiple variables, I, j, k. So I can always write I equal to j equal to k equal to, let's say, all are initialized to 0. This is to be interpreted as, so this operator, so far you have seen left to right associativity, right? So this is right to left associative. In other words, this is same as assign the value 0 to k, whatever is returned, you use that value to assign to variable j, and then whatever is returned, use that value to assign the variable I. So this is done first, then the return value is used to give some value to j, and then the return value is used to give some value to I. Okay, and every time this return value is the value that goes to k, not what is computed. Okay, so this is an important thing and it has some implications, but let me first see that the type of the value returned is of some concern to us. So recall that this was the program that I was modifying. So M, N, P are integer variables, F, G, H are floating point variables, and X, Y, Z are double precision floating point variables. Okay. So what I do, first of all, I compute, let's say 80 point by 3. Okay. I can avoid this point actually, because if one of this is a floating point variable, the other will be automatically typecasted to float, not float, floating point variable. And we have seen that by default, floating point constants are double, right? So this essentially evaluates to 26.666666, right? Now, so this is also a valid C program, although I am not doing anything with this value. Okay. But let's say I am using this to assign the variable m, which is an integer variable. So whenever I have a typecasting from a floating point value to an integer, it is always the integer part. Okay. It's not rounding. So in this case, it is 26.6666. That 0.6666 is simply ignored. 26 will go to m. Okay. Now suppose that I am assigning that value to f, which is a floating point variable, float. Okay. So f will not get the value 26.6666, something like this. Instead, it will get the value whatever is assigned to m, that is 26. So 26.0000 will go there. And yeah, so now this is an integer. So let us see that this thing is what happens. First, let me print this quantity. 80 by 3. Maybe with 10 bits precision, 10 digits precision, and then I will print m. Finally, I will print f. Maybe I just write expression is equal to this. M gets the value this, and f gets the value this. So this is just that expression, 80 point by 3. Then I have m, then I have f. Okay, so let us run this, and maybe we will make a couple of new lines to understand this. This is today's thing. Okay, so GCC -1 all arithmetic.c. Wow. Okay, so this value, which is originally computed, is 26.666666. Okay, 7. It is printed in a rounded form. Then this value is used to initialize m. And whenever there is an automatic transition or typecasting from a floating point value to an integer, only the integer part stays. Okay, it's a truncation, not rounding. So 26 will go to m. And whatever value goes to m, that will be used to initialize f. So f will not get 26.667, but it will get 26.00. Okay.
Sir, question.
You have a question? Yeah, tell.
Sir, actually many questions. Sir, if the first thing is like, since you're setting the precision manually, that is %.10lf.
Okay.
Sir, what if you don't write dot? Like if it's just %2d?
No, you actually, I would say it's very difficult for me to cover everything. So the general thing is something like 16.10. So this says that use a total of 16 characters to print this.
With 10 digits of decimal precision, right?
10 digits of decimal precision. Yes.
Sir, the question is like if I don't put 2 anywhere and it's just like %2d, which means what, like what, two digits of precision.
Let us see. Since you have
Pers-
raised this issue, I'll also say 60. And,
%60, yes.
okay, let us also say 16F. Okay,
Yes.
let's see what happens. Okay, then you will understand. Okay, so I have told 10 digits precision. So that's what it has done. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I told it to use a total of 16 characters. So here I have 10, 11. Okay, it's not coming. This point is 11, 12, 13. So 3 other things are not needed.
So why are you counting the point in the character?
Point is a character.
But we are printing float values. Then also point is considered.
Yeah, point is considered. Point is to be considered as a character. And so I have 10 plus 1 plus 2, 13. So
3 are not needed because
we are not needed, but it is printed like this.
If it was like 1326.66666667, then it would have come, right?
Yes. So now it is 1, 2, 3. 3 spaces are printed. Okay.
Sir, and what 6D means?
60 means use 6 characters. So 1, 2 characters, so 4 characters will be printed.
Sir, okay. Is the 6D means irrespective of decimal point? Like
no, D is for integers. Integers do not mean decimal point. And here I have told 16 total, a total of 16, and without any specification of how many after point. So it takes the default 6, 7, 8, 9, and remaining 7 things it will fill with blanks. Okay.
So can you just slightly explain me the scanf thing, sir? Like %d, %f, when to use d, when to use f?
No, %d is for printing integers in decimal.
Printing integers in decimal?
Yeah.
And %f means float?
Float. And %lf means long float, that is double. Okay. And these are some formatted things, and since I am doing this, so
the last lab class I had some syntactical errors. That is, so they wanted us to print some like long things, that is exponent thing. Like we have to exponentiate using power function of math.h.
Yeah.
And sir, it like specifically I could not typeset despite knowing the formula and everything, and the code did not run because the programs were essentially easy, but I couldn't because there were syntactical errors. The program was wrong.
Okay, just a minute. So let me just complete this. If I say minus, minus, minus here, let us see what happens. Okay, so minus means you are essentially telling it to justify to the right, to the left. So the extra spaces that are needed, that will be added at the end. So 3 extra spaces here, 4 extra spaces here, and here there may be, I would say 6 plus 3, 9, 7 extra spaces here. Yeah. Okay. So that's the formatted thing. But please look at the please look at some book. Okay, to understand how this formatted printf works. Okay, so everything, I mean, teaching everything is a little bit complicated. And one thing, so if I say 0.10 and if I say just use 11 characters, actually you require how many? 10, 13 characters, but you said just 11 characters. So then it will actually do whatever is needed. Okay, it will not truncate. It will actually use 13 characters because it is unable to fit in 11 I would say, characters. So it is actually taking 10 plus 3, 13 characters. Anyway, I think it's a little bit boring to cover these details here. You look at any book and you will find this. Formatted printf things. what I was trying to illustrate is that if you have some cascaded assignments like this, they have to be evaluated from right to left. Okay. And the value that is assigned to M, that will go to F. It is not the value that is computed. That's why this is not 26.66667, but it is 26.0000. Okay. Is that fine?
Excuse me, sir.
Yeah.
Sir, we consider minus as also a character while counting.
Minus is also a character. Everything that you can see is a character,
Okay.
including space. And there are characters which you cannot see, like new line. You can see its effect, but you cannot see. And also I told you something like a null character, which actually you cannot see. This null character, the character with ASCII code 0. This is completely invisible. Okay.
Sir, M is the integer here.
Yeah. What?
M, sir, M, sir, M.
Which M? This M. This backslash M
M,
is
sir, M for man.
M is an integer. M is an integer, F is a float, X is a double. Okay. So double I am not using, but of course I can do to illustrate something a similar thing, that double is also important. So maybe X is a double, right? X equal to F equal to, let me do this thing. And then what I will do, I will print, I have first assigned F. So it should be again maybe 10 F. And then I have assigned X. So again maybe 0.10 F. But it should be LF. Although my compiler does not complain, but it's preferable to be NC compliant. So first this is F and then X. Let us see what happens. Okay. So as a double, this value is 26.66667. Maybe it has a little bit more precision than this. Okay. But this is this. But once this value goes to this float, okay, this is basically an implicit constant. So a constant is always evaluated as double if it is a floating point constant. This is integer. Okay. And this is double by integer. So C will automatically typecast 3 to double. So double by double will be a double value, which is something like this. This is used to initialize F, but F is float, so it will lose some amount of precision. Okay, so that is clearly visible here, right? It has lost some amount of precision. Okay, and then that less precision value is used to initialize X. So X will not get this value 26.66667. Instead, it will get this reduced precision value 26.666600309, whatever it is. Okay. Oops.
Sir, if we make the number of decimals more than 6 in float, then it adds the rest of the digits randomly.
How it does, it is not exactly very clear to me. Maybe it somehow expands whatever is stored. Okay. So let us not worry too much about this. When we study this floating point format, maybe you will be able to understand these things in a better way. Okay. Okay, for most of our computations, whether it is this or this, usually doesn't matter. Okay, they are approximately the same. And in fact, 26 by 3. cannot be represented in a finite binary as a finite binary value, right? This is also an approximation. This is also an approximation. This is only a worse approximation than this. Okay.
Okay, sir. Okay.
Yeah.
Sir, if we put f to the right and m to the left, then what will happen, sir?
Here.
Yes,
In
sir.
this- Then if we, okay, let's see. Good question. What happens if we swap this? Let us see. So here I have m, here I have f, and so anyway, let us print m first and f. Now what will happen? This will be a double value. This will be typecast to a float, and that float will be used to assign this f, that value. And then I am using truncation. So let's run it and see what happens. Okay. So now you see m got the f got the value 26.6666. So the order is very important. M is always 26 here or here, but f has got different value.
Sir, as you told the associativity is right to left, then m should be 26.666, sir.
M is an integer. You cannot store 26 point something in an m. In m. Whenever you are typecasting to m, it is always truncation. Whatever the fractional part is there, just forget.
Sir, but according to associativity, it should be, sir.
No. Whenever I have something like this, here of course I have I, j, k and all integers. But if they are of different types and this value is not 0 but something like 26 by 3, 80 point by 3, then this value is computed. Okay. If necessary, that is typecast to the type of this variable, and that is stored there. And that value is returned, whatever is typecast. And if that type is different from the type of j, it will be once again typecast to the type of this variable, and it is stored there. And that new type that is returned. Okay. And once again, if that is different from the type of this I, it will be once again typecast to the type of I, and that will be assigned. That value will go to I. Okay, that's the rule.
Excuse me, sir.
Yeah.
Sir, I didn't understand. Could you explain once again previous slide, sir?
Which one?
Yes, sir.
Yes, sir. This one.
This example. This example.
No, sir. Another one.
No, I don't understand. Which one you didn't understand? No. In general, let me write down this. var1 equal to var2 equal to var3, or maybe I go to next page. And instead of var, I use something else. Okay. So var1 equal to var2, var3 equal to some expression. So what will happen? This expression is first evaluated. Okay. It has some type, maybe integer, maybe float, maybe double, whatever it is. But if V3 is not of that type, it will be typecast automatically to the type of V3, and that will be stored in V3. So this to this, there may be a typecasting. If the type of the final value of expression and V3 are different, then this value is used to, it is not expression will come to V2. but the value that V3 has got, that will come to V3, and that may once again require a typecasting. Okay. So if this is integer, this is float, then there is a integer to float typecasting. And then finally, this assignment returns this value, whatever V2 has got.
Sir, your voice is tracking, sir. Sir, your voice is tracking, so that's why I didn't understand what you say, sir.
My voice is anyway. Actually, there is too much noise in my quarter. So from here to here, there may be a typecasting if this type and this type are different, and then this value is used to assign V2. So if V2 and V3 are of different types, once again there may be a typecasting, automatic typecasting, and then the new value which goes to V2, okay, that will be used to initialize or to assign V1. And once again, if the type of V2 and V1 are different, there may again be possible typecasting. Okay. So every assignment involves a typecasting if needed. If not needed, it's fine. If it is a case like this, all are integers and you can say I equal to j equal to k equal to 0, then there is no question of any typecasting. So 0, 0 will come here, and then here. But if they are of different types, then there will be some kind of typecasting. Is that fine now?
Yes, sir.
Okay. Okay, so it's just about this. But given this, there are two things that I additionally need to cover. One is, you have seen two things, increment x plus plus, or maybe I say m plus plus, or maybe whatever, and plus plus x. Okay, so both have the same effect, increment x by 1. Okay. Now, since these are also assignment things, so they are something similar to this, x equal to x plus 1. Okay. As far as the effect on x is considered, it's just an increment by a value of 1. Okay. X may be an int, maybe a float, whatever, its value is incremented by 1. Okay. Now, since this is an assignment statement, this returns a value. So whenever you say y equal to x plus plus and y equal to plus plus x, then there is a difference. So here y gets the pre-increment value. And here y will get the post increment value. That means that, so if x was 25, okay, here x is 25, here also x is 25, let's say, the overall effect on x is getting to 26. Here also, here also. So x changes from, let's say, if x is 25 here, x changes from 25 to 26. That's not an issue. But here y gets 25, whereas here y gets 26. Okay, so that is why this is called post increment. The value returned and then you increment. And this is called pre-increment. First increment, and then return that value. Do you want to have a demonstration? Okay, let me.
Yes, sir.
Okay, let us do it. Let us do and see it. M equal to 25. Okay, and let's say n, maybe I write here, n equal to m plus plus. So now I print and if I do just the other thing, so instead of this, I will say n equal to plus plus. Let us see what happens. So first one is post increment. The pre-increment value is returned. So m in both cases will be 26. Here n will be 25. Here n should be 26. So let's see that this thing happens. Oh, I see. I didn't print the things, arguments. Yeah. Okay. The effect of m is same. Is the same in both the cases. Just
Sir, screen is not visible, sir.
yeah. What? No, I didn't understand your question. Okay, the effect of m is always increment by 1. So m is 25, it will be 26. 25, it will be 26. Okay. But which value is returned to n, that depends on whether it's a post increment or a pre-increment. In a post increment, the value of m before the increment is returned. That's why this is 25 here. And here, the value of m is incremented and that incremented value is used to initialize or assign to n. So n gets the value 26 here. Okay, so this is the same for minus minus. Okay, m minus minus and minus minus m. Okay, so that's the only difference. But if you do not use this incremented value to assign to some other variable, then whether you write m plus plus or plus plus m, it doesn't matter. Okay, only when you assign this to n, another variable, then there is a problem. Okay. Then you have to understand the difference between the post increment and pre-increment. Is that clear? Okay, so this is a peculiar.
So sir, this operator moves from left to right, right?
No. This is a single operator. So you cannot say m plus 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 plus. I don't know. It should not be. I don't know whether this is allowed. Let us see. Since you mentioned, what if I do something like this? M plus 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 plus. Will it compile? Let us see. Error. This is not allowed. Okay, so this is an error.
Okay, sir.
Okay.
Sir, in which case we are getting n is equal to 25?
N equal to 25.
Post increment. Yes, sir.
Post increment.
In post increment, sir.
Post increment. Yeah.
Sir,
Post
your
increment
camera
means increment later. Okay. Return the pre-increment value and then increment. That is why this is coming after n. And plus plus means first increment m and then increment. Okay, so this is just a convention, so you just get used to it. There is nothing
Sir,
more serious than that. Yeah, tell.
So if we print the value of m two times in post increment, then second time will we get 26 or will we get 25?
Yeah. No, of course, you can increment it another time. Yeah, no problem. So 25 will go to 26, 26 go to 27, 27 again plus 27 will go to 28 and so on. This will keep on doing. That's not a problem. Only problem is when, but you should not write something like m plus 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 plus. That is not allowed because we have just encountered an error, right? You can write m plus plus semicolon, m plus plus semicolon, m plus plus semicolon. That's okay, no problem. So you should be careful if you want to return these values and store somewhere else. Then which value is returned, that you need to take care of. Yeah, that's the difference. And this is actually a, I would say, bad thing about C syntax. But anyway, things are like this, life is like this, so we have to accept. What can we do? Okay.
Sir, this will work only for integers, right?
No. Let's see what happens. X is a double, right? So let us say 20, okay, 80 by 3. And let's say y equal to plus x, or x equal to y equal to x plus plus. So I will get the previous value, x will get the incremented value. Let us see what happens. After this increment, again maybe %10 LF, and y is LF. First is x, second is y. Let us see what happens. Okay, so the pre-increment value was 26.6667. After this increment, it has become 27.6667. In fact, the same thing works for characters. I do not have character variables. So let me introduce some character variables here. Character C and D. So let's assign C to A and D to C++. Okay, so D will get the previous value, C will get the incremented value. C is incremented, so C and D is this. Okay, let's see what happens. Okay, C gets the incremented value from A to B, and the old value was A. Okay. So this plus and minus operator, plus and minus operators apply to integers, floats, characters, and almost everything. Okay. Yeah, that's it. Okay. So let's not waste too much time on this trivial idiosyncratic behavior of the C compiler or the C language, I would say. But I will just give you a warning about something very important. So this is a very typical mistake. So let us say no typecasting, nothing. You have initialized x to 5, y to let's say 10. Then you look at this. X equal to oh sorry, maybe okay, no problem. Y minus 5. And x, oh, maybe something a little different. Maybe y minus 6. X equal to y minus 6. Okay. So I can use this because this is an integer value. This is not an integer, this is a condition, right? I am checking whether x is equal to y minus 6. What is the result?
False.
False, sir.
It's false. But if I forget this double equality sign, then what this will do, this is a perfectly valid C syntax. So if I say if
Assignment equal to.
so what subtract 6 from y. So 10 minus 6 is 4. That value is assigned to x. So x now gets the value 4. Okay. And that value is returned. So this makes no comparison, but this returns 4. But 4 is what? True or false?
True.
No, it is true, right? Because it is not true. So whenever you actually mean a comparison, you always use the double equality sign. Single equality sign is syntactically a valid C program, no problem. The program will compile. But with minus W all, you may get some warning message. But anyway, don't rely on that. So be careful. So this is just be careful. This is a very, very common mistake for beginners. If you mean comparison, always use double equality. If you use single equality, then this will be an assignment. That assigned value is returned, and this is a syntactically valid C code. Okay, you will not get compilation error.
So, sir, it would always read as true statement.
Not necessarily, depending upon if you say y minus 10, then 10 minus 10 is 0. Okay, so if I say instead x equal to y minus 10, then what will happen? 10 minus 10 is 0, x will be initialized to 0 and 0 will be returned. So now this is false. Right. It depends. Okay. But the idea is what.
Sir, why is last statement false?
Why is 10, right? 10 minus 10 is 0. 0 is used to initialize x. And that value, what x gets, that is returned, which is 0, but 0 is false. Okay, so you be careful. That's my only suggestion. Do not use assignments in these conditions. Okay. Okay, so I think that's about the remaining part from the previous chapter. I will now go to the next chapter, that is called conditions and branching. So conditions are essentially Boolean values to which we are already accustomed to it. Okay. These are Boolean values. Boolean essentially, again, I reiterate that C does not have a Boolean data type. 0 means false, non-zero means true. Okay. So let us see the syntaxes. Basic syntax is something like this. If some condition is true, then you do some statement. If you want a set of statements, so statement 1, statement 2, blah, 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 statement K, then you should enclose this entire thing within a pair of matching curly brackets. Okay. If you have a single statement, of course, if you have a single statement, you can use this, but it's not necessary. Okay. So this is same as if you have only a single statement, you can definitely use this, but it's not necessary. Okay, it's optional. So a thing or a segment of code enclosed between a pair of curly brackets, this is called a block. Okay, this is actually a case statement block, but you can also have a single statement block. Okay, that's also not an issue. Okay, but C is that condition, maybe using equality, conditional and, conditional or, all this stuff. Okay, I will give you several examples. But then, so this is the if statement. There is a closely related thing. If something happens, then I will do something. Otherwise, I will do some other thing. So that is what is called an if-else statement. So if condition is true, then you have statement T, else you have statement F. I will give you enough examples in the rest of today's class. And again, if this is a multi statement block, you enclose it. So statement T1, statement T2, statement Tk. Okay, enclose them in blocks. Else, statement false 1, statements false 2, and maybe statements false L. Okay, so this is called an if-else statement. Is that fine? Okay, so I will give you enough examples. So C is a condition which evaluates to true or false. Under the convention of C, 0 means false, non-zero means true. Whatever non-zero value it is true. And if else means, earlier I have only if statement. Okay. So the else part I am not doing anything. Here else part I want to do something. Okay. So that's the difference between this and shall we see some example? Maybe. Or maybe. Okay, let's see an example. Let's see an example. I will just write down here. Okay. So let's say I have two integer values x and y. And another integer value, let's say m. And I want to compute in m the maximum of x and y. So this is easy. If x is greater than or equal to y, then this is a single statement. So I can simply say m equal to x. I do not need to enclose them within a pair of curly brackets. Although if I do so, there is no harm. Okay. Else the maximum value is y. Okay. So trouble comes.
For more than one.
Yeah.
Hello, sir.
Yeah.
For more than one statement, we have to use curly brackets.
Yes. If we read multiple statements, then using the curly brackets is mandatory. Otherwise, what will happen if you say something like this? If condition statement 1 statement 2. Okay, if we write this way, so it will do this statement 1 conditionally. Okay, so this is conditional, whereas this is unconditional. Irrespective of whether the condition is true or false, this will always be executed. Understand? The scope of this is to this statement only, if you do not give the curly brackets. But if you say this, statement 1, statement 2, then both are conditional. Okay, so this may be yet another source of error. Okay. And there is actually another source of error. Sometimes a few students, they do something like this. If C, semicolon, statement 1, statement 2. And you will see that both statement 1 and statement 2 are executed. Okay. So now by using this semicolon here, okay, what you have done, you have essentially declared an empty statement. Okay, and so these have now become unconditional. It will always be executed. In fact, if you say something like this, okay, once again, the scope of this if is restricted only to this null statement. This is another block, so this is unconditional block. Okay, so these things will happen. If you by mistake add a semicolon here, then there is a problem. Okay. And with my experience with the lab sessions, I know that in a few cases, this kind of errors will happen. So you say I have put these things in these curly brackets and still these things are executed irrespective of the condition. So the culprit is here, the null statement here. Okay. So be careful. Okay, so that is about max value. But what happens if I want to compute the maximum of 3 quantities? Now I will explain that this can be done in several ways.
Excuse me, sir.
Tell.
Excuse me, sir.
Yeah, tell.
Sir, the empty statement will always be false.
No, empty statement will always be false. No, the question is, because of this semicolon, here you can actually see an empty statement. But inside this condition, I cannot have this semicolon. So if I say only if opening parenthesis, closed parenthesis, then this is not a valid C program actually. Something should be there. Okay. So empty statement you cannot put inside this condition. This is without semicolon. Okay. Yeah. So whether it evaluates to true or false, it doesn't matter. You cannot put it here.
Okay, sir.
Okay. Okay. So now let us see a second example. Suppose now I have int x, y, z. And once again, I want to compute the maximum of m, maximum of x, y, z in m. This is a threefold maximum. Okay, so you can see M can be assigned either X or Y or Z. So a single if else will not suffice, right? It cannot be used. So I have to do something extra. So this is one way of doing it. If X is greater than Y, else, then what you know, if X is already greater than Y, Y cannot be the maximum. So now you compare X with Z, whichever is bigger, that thing will win. So X is also greater than Z, then set M equal to X.
So why can't we include this x greater than z condition in the same block itself, like x greater than y and x greater than
I
z?
will come to that. I will come to that because that will illustrate something else. I will come to that. Okay, greater than Y or greater than equal to Y. Okay. Otherwise, or maybe greater than equal to. Let me use greater than equal to.
Sir, here Z cannot be less than Y.
Just a minute. Greater than equal to Y. So X is already bigger. Okay. So Y is smaller than X. Okay. Not bigger than X. So there is no need. So Y cannot be a candidate for this maximum. By a single comparison, I have essentially thrown out Y. Now I will compare X with Z, whichever is larger. Again, you can use equal to or greater than equal to, doesn't matter. In case of ties, it's fine. Whichever value goes, not a big issue. Okay, greater than equal to. Anyway, so otherwise, if X is less than Y, then X cannot be the maximum. So Y can be the maximum or Z can be the maximum. So you just compare Y with Z and say M equal to Y. If Y is the larger one, else M equal to Z. Agreed? So this is another example of if and else. Now inside this, you have another if else statement. So this is what is called a nested if statement. Okay, this is nested inside this block. Okay, and next question is this, and this. Are they necessary? What do you think?
No, sir.
They are not necessary. Because essentially this is a single statement. This is a single conditional statement. So you can also avoid this, and this. Okay. Yeah. So
And sir, we can also write it in a same line.
Yeah, you can write it in the same. Yeah. But I would suggest that you do something which becomes makes it easy to understand. Okay. If you write it here, it becomes a little bit complicated for humans to understand. Just write it here, it will look neater. Okay. Although for the compiler, it doesn't matter. Okay, but it's good to have good indentation so that the person who is viewing your code will find it easier to understand. Okay. Yeah, so that's important. So this illustrates one thing. If statement is actually, although it's not a single assignment kind of statement, but this is still a single statement, and therefore you can avoid this, and this. Okay, no problem. Okay. Now, as
Excuse me, sir.
Yeah.
there is no predefined function to find maximum of given n numbers. Here 3 was there, so we
You check. STD leaf may offer you some possibility, but I am not very much sure. Okay. Yeah, I am not very much sure.
If we have to find the maximum from the 4 or 5, then
Somebody tried to say something, but nothing came actually. I think a max is not there in standard C. It's not there in C STD leave also. I don't think so. Yeah, we can verify it, but anyway, let's go to more details of this conditional statements. Okay, so this is a three-way max calculator. Then somebody mentioned.
Sir.
Yeah.
Sir, are ternary operators allowed in C?
What operators?
Ternary operators, ternary conditional
No
operators.
ternary operator. Ternary. No, I do not remember any ternary operator in C.
Okay, sir.
Okay. Yeah. Okay. So here is another way of doing it. So one second.
Sir, I guess ternary operator is allowed in C. In C also we have ternary operators.
What do you mean by ternary operator?
So ternary operators is like, I mean, giving a conditional statement instead of using if else, we do it directly by giving a condition. Then if it is true, we print one. If it is false, we print
Wait. I will come to that. That second, 1 second, short circuit thing. I will come. But one by one, let us understand these things. Short circuit thing will come at the end. Okay. So, okay. So here is another way of doing it. 1 second, let's say XYZ as if X is greater than equal to Y and X is greater than equal to Z, then you know max is X. Else, okay, if, sorry, Y is greater than equal to X and Y is greater than equal to Z, then max is Y. Else, max is Z. Okay. So this is also a valid program. So first of all, you see that I have used this logical connective and. Do not use a single and. Single and, single or these things, these have some other meanings. Okay. So like equal to always use double versions. So they have other meanings. And let's not worry too much about the other meanings. Okay. So once again, this may be a source of error. Use and instead of only a single and. Like or. Okay, so these and or are bitwise operators. They are also valid, but they have completely different meanings. Okay, so yes. Okay, so if this thing happens, then this, else this thing happens, then this, else it is this. Okay, so you have a set of something like this. If condition 1, if necessary, use block 1. Else if condition 2, block 2, else if condition 3, block 3, and so on, maybe else block 4. Things like this. This is doable. But if you do not use this, for example, if your blocks are single statements, then you do not need to use this. Then also the order is like this. Okay. So let me see how I can make two different meanings of this. Okay, no, here I cannot have any two different interpretations. But anyway, so is this fine, this program? That requires a different example. I will come to that. Let's say that this is fine.
Sir.
Okay, this is fine, right? Yeah. So.
Excuse me, sir.
Yeah, tell.
Sir, in else if you write y greater than equal to x, sir, it is correct also since it is negation of if statement.
That's not needed actually. No.
Y greater
no. It's needed. So if this is not satisfied, then either y is greater than equal to x or z is greater than equal to x. Or y is greater than x or z is greater than x. So this is still needed, I believe. Because you do not know for which reason I have come here. This may be true. Okay. But this is false. That's why I have come here. Okay. So this is fine. Okay. So here you have no problem. Okay. So maybe I have a few animations. I will just quickly show those things. And now suppose I do something. If condition, if a second condition, condition prime, let's say, then I say maybe statement 1, else statement 2. Okay. So now you see that this code can be interpreted in two ways. Okay, because I have not used explicit curly brackets. So one possible meaning is that if C, then else S2 and close this. And the second possible meaning is that if C prime S1 bracket close, else S2. Both are possible, right? First, convince yourself that both meanings are possible. Okay, this thing I can mean by this. Okay, by this I may mean this or this. Both are allowed, right? Okay, you tell me whether you understood the difference between these two.
Yes.
Okay. So it is similar to situation like
since the in the first that top left corner, since there is only ultimately one statement to be executed, so we don't require the curly braces.
No. The point is that if there is only one statement, we do not require curly braces. But if I use curly braces, there is no harm. And what I wanted to highlight in this context is that this may mean this or this, both are valid interpretations. Yes or no?
Yes, sir.
Okay, so that's what I am trying to, I would say, highlight by using by giving this peculiar syntax. So it may be interpreted this way, it may be interpreted this way. So it turns out that this is the correct interpretation, this is not the correct interpretation. So this else will go to this if or this if. C's rule is this will go to the last if. Okay, I may have some other if D, okay, and else may qualify this if or this if or this if, okay. So this rule of C is that whenever it sees an else, of course, if you have explicit curly brackets, then of course the C compiler does not have to guess. But if you do not use curly brackets, then this will correspond to not this if, but this if, because this is the later if. Okay, so that is the important thing. Okay, so that is why this is the correct interpretation, this is not the correct interpretation. Okay, so well, I am running a little late, but anyway, let's see a few more, I would say, so I do not think it's too much necessary. Okay, I have to open. Okay, so let us quickly look at this. So it's just a simple if statement without any else. N is assigned 91. So before if, now this condition is true, so it will print a lot of things. I have enclosed these things within a pair of curly brackets. So it will print 91 in several languages. Okay. And then after it. But if I initialize this to 19, then it will print this before if. Okay. Now this condition is not true, and therefore this entire chunk is skipped, and I will come here after if. Okay. So that's a simple-minded thing. And then, okay, I cannot run it this way, so I have to once again load it. Then there is some if-else thing. Okay, so 91 before if. Okay, now this is true. Therefore, this block is executed, will be executed. So 91 and 96, those will be printed, and then this. Okay. And if it is 19, then this is ignored, this will be executed. So let's once again see before if printed. This is false, so this else part will be executed. So not 91, not 91 after if. Okay. So this is once again a simple-minded thing. Maybe there is another if else. Okay. So this is if else. So of course here I have explicitly used curly brackets, so there is no problem. And in fact, in this case, of course, we do not have any problem. So if before it is 91 equal to, this is true, so it will come here, and then it will simply go here after this. Okay. Otherwise, if I start with 93, this is false. Okay. So this is false, so it will go to the first, this else. Okay, so this is false. So now this is true, So this 2 will be executed, and once again after this, after if. Okay. After if. And if we start with 89, once again I will print before if. 91 false. This is 89 greater than 91. This is also false. So this else, now this will be printed. Okay, that's it. Fine. So I think these examples are fairly straightforward. And what is perhaps not straightforward? What is this language? Do you have any idea?
German.
German. Okay. Okay, so that's it. Yeah, so okay, so yeah.
Sir, in the previous example, in the place of last else, can we write else if?
Yeah, anytime you can. Else if something, 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 and finally else, and the final else also you can omit.
Okay, sir. Okay.
That you can do. Okay. So now, first of all, I would like to cover a couple of things. First of all, once again a short circuit thing, and then there is something called, okay. So if you have something like this, if condition, then variable will get the value of expression 1, else variable will get the value expression 2. Okay. So if we have a situation like this, then C once again provides a shortcut, but it applies only to this. The shortcut is V equal to condition, is it true? Yes. Then E1, else, no, it is not true, so E2. Okay. So this is a peculiar syntax in C, but you can use these things. For example, if I have maximum of m equal to max of xy, you can write it this way. M equal to, is x greater than equal to y? Yes. Then it is x, otherwise it is y. Okay, sometimes it is the handy way of doing it, but it only applies to this situation when you are assigning expression 1 to a variable v, and else part also you are assigning to the same variable v, but possibly different expression. Okay. So once again, this is a kind of syntax, and no problem, right, with this?
No, sir.
No, sir.
Okay.
No,
Fine.
sir.
Okay, fine. So this is just a matter of syntax. So this way also you can slightly reduce the size of your code. Okay. Anyway, it's nothing so great, but anyway, it's okay. The final thing that I would like to cover today is called the switch statement.
Sir.
Yeah.
Sir, writing this shortcut or this ternary of using this ternary operator, if we do conditional statements, then does it save time on running the loop or the runtime, or is it same as using an if-else statement?
I don't think there is any say performance say difference you can see. I think running time will be the same. Okay.
Okay.
I think so. Because modern day compilers are quite intelligent, so even if you write, irrespective of whether you write this way or this way, I think it doesn't matter. Okay.
Just the statement is shorter.
That's the thing. That's why I call it short.
Yes.
as if you cannot write x equal to x plus 2. Instead, you are writing x plus equal to 2. So you may be avoiding just one space or two spaces and one x. There is a similar thing is happening here. Okay. Sometimes, I mean, since this is quite compact, sometimes it is useful. Okay. For example, I can simply write printf %d, 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 and x, y, and this max thing. Here you can simply use this construct. Here, of course, you cannot use this complete C if-else statement, but you can use this.
Yes, sir.
Okay. So this is a little bit handy thing and nothing great. Okay. Yeah, that's it.
Hello, sir.
Yeah.
Sir, when we use the shortcut, then we don't have to use if statement.
The point is that this is applicable only to this situation. Based upon the condition, you are assigning the same variable. If it is V, it is W, then of course this statement makes no sense. Okay, which one will you assign? Okay, so it applies only to this specific situation. And that may be useful somewhere here like this. Okay, so instead of using a new variable to store the larger value, I can simply print it online like this. Okay, so that's it. Okay. Yeah, let us see. Let us now. Okay, half an hour time. So I will start with the switch statement. Okay, it has some kind of oops. This is like oops. Okay, this is like, okay, so let me first write down case value 1. Then you do something. Case value 2. Then you do something. Case value 3. Do something. And finally use a default. This is in intent same as if E equal to V1. Okay, let me give it some name. Here you have some, maybe a block or maybe a single statement, maybe block 1, block 2, block 3, and this is block D, default block. Okay. So then block 1, else if expression is equal to value 2, then block 2, else if expression is equal to value 3, then block 3, and so on. Eventually you have one else, the default block, which may or may not be present. Okay, and this else is anyway optional. So,
sir, is it necessary to use else if? Can we use if means all time if we can use?
It's a difficult question. Of course, in some example, it is required.
Sir, in slab type problems, I think it is required. Else if.
No, the point is that this block may actually alter the value of the expression.
Sir, if we use if every time, then it would all I mean take the statements every time, and I mean a news as in the form of a new statement. So if we previously block some of the conditions in one of the if statement, and if we do not apply else if statement, then that condition will be included in the next if statement, and due to that some wrong results may be printed.
This expression may involve some variables, and this block may change a variable, change that variable. So if we do not have else, that expression will be evaluated with the new value of that variable. And this condition may again be true, right? This condition may again be true. So this is executed, this is also executed. So this is not the intent. Okay. So what I say, the switch statement, my intent is something like this. But there is a very peculiar behavior of this switch statement. So let me illustrate this by this example. Okay, file, open. Switch, where is switch? Okay. Okay, so suppose if n is 2, I will print 2. If it is 0, I will print 0. If it is 1, I will print 1. If it is 3, I will print 3. If it is 4, I will print 4. Otherwise, the default behavior, I will just say bigger than 4. Okay, this is the intent. And with this intention, I have written this code. But there is a problem. Let us see what the problem is. Okay. So switch n, the expression is n, this evaluates to 2. Okay, so this you are just entering. Case 0, no, this is not case 0. Match does not occur. So you go to, you are now comparing that n with 1. So once again, this is unsuccessful. So this is not match. Okay, case 2. Now there is a match. So this will be printed. Okay, executing print command, 2 is printed. Now we expect this because if this works in this manner, we expect, oops, lost it here. Okay, you expect this to come out, right? But this will not happen. Instead, what it will do, it will keep on printing 3, 4, bigger, everything. Okay. Now, this is once again a peculiarity of C syntax. As soon as there is a match, after this, whatever follows, this will be executed. So once again, let us look at this. N evaluates to true, 2, no match, no match, match. Once there is a match, after that, C will not look at making further matches. Once match is done, so it will keep on print, 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 print. So that is the default behavior of the switch statement. Don't ask me why people design the C language this way. I don't know. I didn't design it, but this is the behavior.
So in this case, won't there be a fall through? Like we have like case 0 if we go, like case 2 if we go, then case 3, case 4. Like in order to prevent that, we have to give like that.
So if you start with n equal to 0, it will print everything 0, 1, 2, 3, 4 bigger.
Yes, so that only I'm saying.
Yeah, yeah. So the moment there is a match, the rest of the statement, the rest of the switch block will be executed one after another. There is this case 3, case 4, they are no longer relevant, no longer important. Okay, so that's the default behavior. But you can actually modify this default behavior to mean this. Okay, so this is how you can do it. Open switch with break. Okay, So once again, let's start with n equal to 3. If I do not have these break statements, so 0, no match, 1, no match, 2, no match, 3, yes, there is a match, so it will print 3. And then if there are no break statements, it will go and print 4 and then bigger. Okay. But if you use this explicit break, after printing these 3, this block will be broken. So let's see what happens. 3, no match. 1, no, 1 is not same as 3, no match. 2 is also not the same as 3. 3, now there is a match. So then what follows this colon, this will be executed. Match occurs, so 3 will be printed. Okay, but then you are asking this switch to break. Okay. Therefore, it will no longer print 4 or bigger. It will now come to this end. Actually, this gives you quite a lot of flexibility. So for example, if you did not have this break here, but break here, okay, if this was not present, then just 3 and 4 will be printed, right? Yeah. So this gives you a lot of flexibility, but anyway, it's something a little bit peculiar of a construct for a C with the switch statement. Okay, so is that clear? So we will look at better examples of break later, but this is another situation where this break applies in a switch statement. Yeah, so let me know if you are happy with this peculiar behaviors of the C language. Or doesn't matter. Okay, so maybe I will just give you a fancy example how you can use this particular peculiar behavior of C in a switch statement, something like this. Suppose that so I want to compute something like I plus 1 up to 10 for some value of I between 0 and 10. Okay. So I can say sum equal to 0. Now I can say switch I. Case 0, or maybe I start from 1 because 0 means just adding 0 to it. Sum plus equal to 1. Case 2, sum plus equal to 2. Case 3, sum plus equal to 3, and a few other lines I have to write, right? So not writing. Case 9, sum plus equal to 9. Case 10, sum plus equal to 10, and there is no default here. Okay, then if I is some value between 1 to 10, then this actually computes this. Okay, the moment there is a match, after that it will keep on incrementing. Let's say I is 3, so plus 3, plus 4, plus 5, plus 6 up to plus 10. Okay, so this may be a fancy and I would say useless example of switch without break, but anyway, the language is like this. What can we do? Yeah, so that's about if statements, and maybe let me find out whether I'm missing anything. Yeah. If you have a question, please let me know. Then I will just
Sir,
check.
please explain this example. How is it calculating the sum up to 10?
Okay. Maybe let me write. There are a few more lines. S plus equal to 4, 5, S plus equal to 5, and 6, 7, 8. I also think about this. Too many lines. Okay. So let's say I is 3. So this evaluates to 3. 3 is not same as 1, so this is skipped. This is not same as 2, this is skipped. So, but now there is a match, case 3. So 3 will be added to the sum. Okay. And then you did not write break. So now this comparison is disabled, but it will keep on executing the rest of the statements. So some will be incremented by 4, some will be incremented by 5, some will be incremented by 6, 7, 8, 9, and 10. So starting from 3 plus 4 plus 5 plus 6 up to 10. All this thing will.
Sir?
Yeah.
When S gets incremented by 3, so I becomes 6?
No, S.
Oh.
S and I are different variables.
Okay. Yes, sir. Okay,
Okay.
sir. Okay.
Yeah. Hey, this is a fancy example and as such useless, because we will see how to do it more elegantly using loops tomorrow.
Hello, sir.
Yeah.
So if we take I is equal to 0, then it will be executed or not?
Equal to 0 means then no case will
match. Yes, sir.
no case will match. So therefore, nothing will happen. No
Okay,
match. Every time you will enter no match, and then you will simply S will remain 0. Yeah. Yeah, so what I will do, I hope I have stored it somewhere. Let me see. Okay, let me see just whether I have missed anything. Yeah, so this is standard larger thing. This is also conditional branching if. Okay, so here are some other examples on, yeah, you look at this if, else if, else if, else. So this is fine. Yeah, so you may have single statements somewhere and then you have multiple statements. So if these are multiple statements, so use curly brackets. Otherwise, you can mix both these styles. Okay. Here also you can use curly brackets, but it's okay. Yeah, larger of the 2 numbers, larger of the 3 numbers. So yeah, this is what I have already covered, assignment and equality. This is very important, nested else if. Yeah, this also I have illustrated. Yeah, I think I have covered almost everything. The conditional operator, yes, switch statement. Yeah, I think it's fine. Break.
Excuse me, sir.
Yeah, tell.
So I have a doubt in, so when we are using if, should we use the curly brackets, sir? I mean, when should we use the curly bracket? When we are using the if statement.
Just a minute. Open this. Yeah, what is the question?
When we are using if statement, when should we use the curly brackets?
curly bracket is mandatory if there are multiple statements. Okay. If there is a single statement, then you may or may not use the curly bracket. Okay. It's your choice. But if you mean that conditionally multiple statements will be executed, then this curly bracket is mandatory.
Okay.
Okay. Yeah, so that's it. So you tell me if you do not have any question, maybe I will just give you a very brief description about loops. Tomorrow I will anyway cover these things in detail.
So can you give an example of tree-like problems using
What?
tree-like problem, sir? So tree-like problem, branching problem.
Tree-like. I think I have an example, but I just didn't cover it. So once again, yeah, BDS, SWF, nested if. I think I have some example like this. Okay, so this is a kind of tree. So as you claim, so it's something like this. So here I am just checking. Okay. Yeah, whether M divides N. Okay. If so, yes, no. Then I am checking whether the language is English or anything else. So this is another. Here also the same thing. Yes, no. Yes, no. So this is what you meant, right? Tree like. Okay, so this is what you meant. I believe so. So
yes, sir.
Yeah. So let's say M is 17, N is 68, and language is English. Before if it is printed anyway. 68 is divisible by 17, so this block will be executed. Language is English. Currently it is English. Okay, so it will say print M divides M. And then this else will not be executed. This else will not be executed. Simply it will come to this print and will print after if. Okay. What if I start with something like this? 1959 and the language is G, German. So 19 does not divide 59, that is 59 is not a multiple of 19. So this will not be executed, it will come here. This is also not true because language is now G, so this will be printed only. Okay, let's see. This is anyway printed. This is false, so it will come to this else. Inside this else, this is checked first. This is also false. G is not equal to E, so this else is executed, and this is printed, and then anyway after this. Okay, yeah. So maybe it's something like this. Anything else? Yeah, and there are actually 4 cases, so one by one you can. Now this will be printed, right? Because 58 is not a multiple of 21, and the language is English, so this will be printed. So let's just see. Before if, no, this is not true, so this else will come, but the language is English, so M does not divide N. Okay, and then Yeah, so like this. Anyways, these are still, I would say, simple and fancy programs. But the idea is that unless you use some kind of loops, it's very difficult to write meaningful codes. And possibly that is the reason on the very first day, teacher has given you a little bit a flavor of loops. Anyway, your lab teachers. Yeah, so you tell whether I should go to a little bit on loops or it's 4:54. Now it's the peculiar time. Maybe I'll just give you a brief idea what loops are. So a loop is for doing the same block or statement multiple times. So one is called a precondition loop. The other is called post-condition loop. Okay. So in a precondition loop, if a condition C is checked, and then if that is yes, then you execute, let's say, a block of statement. Sometimes this is called the body of the loop. B may be body. After that, unconditionally, it once again goes to the top of the loop. So once again, the condition is checked. If it is yes, once again, this block is executed. Again, you go unconditionally to the top of the loop. Again, check the condition. If it is again yes, this is executed. This is executed as many times as the condition is true, or so long as this condition is true. If it is no, then it will proceed further. Okay. This is what is called a precondition loop. Okay. In a post-condition loop, on the other hand, you do not evaluate a condition in order to enter the loop body. But after the body is executed, this condition is checked. If it is yes, once again go there. If it is no, move forward. Okay. So these are two types of loop in common practice. This is called precondition because before entering the loop body, you are checking for the condition. As long as this is yes, this will be executed. Okay. And whenever the moment this condition becomes false, it will come out. And here it is post condition. This means you first execute the loop body and then check for the condition, loop condition, continuation condition. If it is no, you move forward. Otherwise, once again, execute the same block. Okay. So in fact, tomorrow we will see this is what is called a while loop and a for loop. Whereas here I have an example of a do loop. Okay. So we will see the syntaxes of these three types of loops and a few examples. And after we are exposed to loops, then we can actually do a lot of meaningful computation. Yeah, so maybe I think it's good enough for today. Okay, so I will start loops tomorrow. So C is condition. And B is body, which may be a single statement or a block.
Hello, sir.
Yeah.
So Actually, our first assignment of PDS lab was very tough, sir. Most part were asked which was not taught in the theory class.
When our PTS assignment was held at that time, we were not taught, in the class, we were not formally taught the if-else conditional statements and
Yeah, true. So
and all, but the questions involved those things with
yeah, so
JEE advanced level coordinate geometry also.
of course, I told you that I will talk with the teachers, and from this week onward, I believe they are in perfect synchronization with whatever I have covered. Okay, the first assignment is always a difficult.
So, sir, the first assignment will not be considered for evaluation, right?
That you talk with your teacher. This is not in my prerogative, right? This is not in my.
Because other sections lab assignments we have seen, but they were way more easier than ours.
Yeah.
Yes, sir.
Yes, sir. They were supposed to print "Hello World."
Yeah, that's true. But anyway,
yes,
it's up to the teacher.
but our are very tough.
Yeah. But yeah, don't worry too much about this. I hope from this week onward, the teacher will be perfectly in synchronization with my coverage. So, but what I learned from a teacher, this was, I think, section 1. Oh, no. Section 1. No. This is somewhere else. No, forget it. Yeah. No, forget it. Anyway. Okay. Anyway, forget it. Yeah. Yeah, so you just tell if you have any questions.
No, sir.
Okay, then let us call it a day. It's already 5. Okay, so.
Thank you, sir.
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 Okay.
Thank you, sir.
Thank you. Okay.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Bye.